If a $26,000 drone repair can be done in the field, but policy says it has to be shipped back to the manufacturer, do you really have a reliability problem or a repair access problem? Welcome, or hopefully welcome back to Reliability Matters. I'm your host, Mike Conrad. Today on the show, I'm joined by Willian Santos, International Sales Manager at ABI Electronics and a global advocate for the right to repair movement. William recently wrote a compelling article titled Readiness Through Repair, How the U.S. Military is Strengthening Capabilities with Right to Repair, where he explores how repair access, or the lack of it, directly impacts mission readiness, lifecycle cost, and operational resilience within the U.S. military. For decades, highly trained military technicians have been prevented from repairing mission-critical equipment due to restricted access to diagnostic tools, software, and spare parts. That model is now being challenged. In April 2024, the U.S. military announced plans to embed right to repair provisions in both new and existing contracts, a major shift with enormous implications for reliability, sustainment, and cost control. Today, we'll unpack what this policy change really means, why repair capability is inseparable from readiness, and what lessons commercial industry can learn from the military's pivot toward repair empowerment. My conversation with Willian Santos begins right now. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hey, Willian, how are you? Nice to see you.
Hey, Mike. Hi. It's good to be here. Thanks for having me, and thanks for reading my article as well. I appreciate it here.
Well, if you have one click, that's me. One down, a few billion to go, right? Before we dive into right to repair and military readiness, tell us a little bit about your background and how you became so deeply involved in repair advocacy.
I joined the industry 25 years ago. Just obviously for your viewers, benefit. I'm the head of sales and marketing at ABI Electronics. I've been with the company for 19 years now. And my experience is in not just in defense and aerospace, working with defense primes and agencies, but I also work closely with the wider critical systems industry. So that's rail transportation, energy, semiconductor manufacturing, automotive, obviously also aerospace and aviation and defense. And across these different sectors, one thing was clear to me from the moment that I really joined the industry, which was the fact that the average age of people working in electronics repair in maintenance was probably late 50s and into early 60s. And that was in around the 2000s, and then obviously that continued in the 2010s as well. And when you would approach a manager and talk about the plans for the future, the future was looking quite bleak for the majority of these organizations, and much of that lack of vision and plans and aspiration for the future came from what you just described, was some of these anti-repair tactics that you just described that were starting to become more and more popular within the critical systems industry. So a lot of these strategies, anti-repair strategies that are pushed out by consumer electronics have made their way into the critical systems industry, and many companies just allowed that to happen as well, and allowed that risk aversion to be cultivated. And I noticed that we had to change that, because at the same time that we were not seeing like the succession plan being well established by managers and so forth for when those people eventually retired. Some people were even being brought back from retirement to repair PCBs, and that's still the case today. We could see a disconnect, from education as well. So we started to see technicians and engineers completing their courses without even knowing what a PCB really looked like. Never worked on any PCB, being incapable of identifying devices on a board, for instance. So that disconnect plus an aging workforce working in repair, in maintenance, really sort of motivated me and my team here to in 2015 launch the Repair.With movement. And the Repair.With movement exists to challenge that status quo and really encourage organizations to rethink their strategy when it comes to asset lifecycle support and develop their own in-house capabilities, bring back that ability to repair rather than just replace circuit boards. Replacing circuit boards is incredibly wasteful and is a key contributor to the increase of e-waste. The world crossed into 60 million tons of e-waste produced in 2024 alone. And about a third of that e-waste comes from industry, comes from rail, comes from defense, comes from aviation, and so forth. So we've been, working here very hard, the last, several years to try and sort of change that.
I'm just grateful the medical industry hasn't taken up the same practice of, whole system replacement. Can you imagine if you break your arm and now all of a sudden they put a, call out for an arm transplant? That would be a little bit overkill. You mentioned you work at ABI. I mentioned that in the ABI Electronics. I mentioned that in the intro. How did your role at ABI shape your understanding of sustainment versus replacement? Did you come to ABI with that already kind of in your blood, or did your relationship there kind of foster that or increase that?
Yes, I think there's a lot to do with the latter, because obviously ABI has been in the industry for over 40 years, 43 years, and we've been doing sustainability from day one. The company was started by a local design engineer working in PCB design, who one day he was in the office and he stepped onto an IC, and noticing that there was something stuck to his shoe, he stopped, picked that up, and he asked himself, I wonder if this device still works. And back in the 80s, components would sell for about $50 a pop, and test equipment wasn't readily available, super complex and so forth. So he actually decided to create a business and develop what was going to become the world's first low-cost IC tester. And that was how ABI started. And throughout the company's relationship with Ministry of Defense here in the UK, especially the RAF, we have developed a range of solutions for testing components in circuit, then eventually reverse engineering and so forth. So I joined the business in 2007, and coming from my native Brazil, where we do have a culture of repair, a very strong culture for repairing stuff rather than just throwing things away when they break down. I think it was kind of a match made in heaven type of thing, because I could sort of feel where the company was coming from, and we could sort of work together to try and make repair not just feasible, but really empower companies and technicians and engineers to carry out these repairs themselves. And everywhere we go, when we establish these relationships with the critical systems industry, with companies operating in this industry, and we bring technicians and engineers on board, they really like our message and our approach, because it's a way of increasing their value within the organization as well. No one wants to just replace circuit boards and throw them away. No one takes pride in doing so, and no one enjoys doing that.
There's always a kind of a fateful moment where a company is born. In this case, it was a through-hole device sticking to the founder's shoe. Can you imagine if the founder was 30 years younger? He could never start the company today, because surface mount components probably don't stick to your shoe, right? So
that's true.
Thank God for through-hole devices, right? That started ABI, that led to you working here, it led to us talking today. It was a very pivotal moment. What inspired you to write this particular article, which became the theme of this episode?
I think is obviously the realization I think there is a new awakening within the defense sector that we shouldn't be allowing, the industry shouldn't just be allowing to be taken as just custodians of equipment by the primes and the design authorities. And they should be actually, going back to their roots and going back to the principles that, sort of was commonplace in the 70s, in the 80s. It's your equipment, you paid for it, you own it, so it should be your responsibility to, or within your authority to decide how we want to be repairing it and keeping it going. So it's great to see the right to repair being mentioned by the U.S. Army, and the U.S. Army is the U.S. military is incredibly, a big focus and a big, obviously, reference within the defense sector around the world. So I've been watching the right to repair movement since its inception, since its beginning in 2017, and it's really great to see that this is eventually being discussed by the military, and obviously we fully support that initiative.
Yeah. Of all industries to embrace this, I would have thought the military would have been the very last for, fairly obvious reasons. But we'll get into that in a little bit. From your perspective, when did repair stop being seen by OEMs as a capability and start being treated as a liability?
Well, I think it spires from the change from bespoke solutions, because the military used to buy bespoke technologies, and in the 90s the industry changed its focus to COTS, so commercial off-the-shelf solutions, which are in most cases industrial commercial designs that have been tailored for military applications. Now, those systems, obviously, they have a different life cycle, because they are designed not with the military in mind necessarily to begin with, but mostly the commercial, the industrial sector. They become obsolete much sooner compared to bespoke technologies. And the military program can easily last 30, 40, 50 years. Now, rather than identifying an opportunity to create more value, generate more value by working with the end users and fostering local repairs and maintenance, OEMs thought, what? I think we can, we can potentially make a lot more money by discouraging repairs and kind of labeling technology, PCBs, as impossible, something that is impossible to be repaired, and forcing end users to bring equipment back to them for maintenance and repair as well. Now, this is obviously wasteful. It causes downtime. It obviously has the ability to impact entire operations. And but the way that OEMs try to do that is by instigating fear, risk aversion, as we discussed, and claiming that this will be warranty will be void and null, and there is a liability risk by doing repairs, and sometimes it's just a matter of a flat cable that went wrong, a transistor cap that went wrong on a PCB. Surely, if we are able to identify that faulty device, replace it like for like, following the correct standards, following the IPC standards and all the correct standards, surely that system should be as good as new. But unfortunately, rather than investing in servitization and trying to in focusing in value creation by working with the end users and creating capabilities to within the end user to enable them to do a better job when they need to repair assets manufactured by, primes and so forth, they try to sort of stop that, claiming that, you could be breaking their IP even.
Yeah. But do you think the motivation to barricade entry into all the critical areas of a machine or a product came from a place of wanting to protect the product, or came from a place of wanting to exploit the customer financially, or a little bit of both? Where do you think that came from? And I'm sure it varies from industry to industry, but what's your take on that?
Well, it's I think it's a combination of both aspects, but I would tend to say that it's more about the latter than the former. I think it's really more about protecting revenue, and the reason why I say that is because obviously I listen to both sides of the arguments. We work with both sides of the aisles here, so with the end users as well as OEMs, and unfortunately, the vast majority of OEMs do not offer the level of service that you mentioned, which is fault analysis, fault logging, repair down to IC level, for instance, on a PCB. They just swap their boards, swap PCBs. They in a large proportion of the OEMs that supply technologies, critical systems into the industry, they don't make the electronics either anymore. Designs are done in one country. The design itself is fragmented. Manufacturing is even more fragmented, and things are put together in a third country, then eventually shipped to them. Now, because they are no longer in control, if you as the end user, you are led to believe that this is the only, going to the OEM is the only solution, you could find yourself sat and waiting for parts for months and months, if not years. There's a large UK manufacturer of helicopters, European manufacturer with a base here, a footprint here in the UK. And I was speaking to their obsolescence lead, and they said, look, if we need to replace a PCB, if we need to get a new circuit board out to one of our customers, it could take 3 years to get a new one. So if we did have OEMs seriously concerned about their products' reliability and protecting their products, surely they would have a better supply chain arrangement and a better option to offer to their customers, and that's unfortunately not the case. And as I mentioned the word obsolescence, that's another problem that we have in the industry, which is equipment is circuit boards, electronic components, they are not on an unlimited supply. It's quite the opposite. This has been the case for many years now, even before the pandemic, but even more so after the pandemic. We're seeing supply chain being heavily affected by shortages, and when components become on short supply, obviously PCBs suffer, the production suffers, and we're seeing more and more systems being phased out and so forth.
I think another argument against blocking access for repair is kind of a more practical one, and that is if you eliminate the majority of the profit center, or you reduce the amount of profit there is in after warranty repair, I would think that most manufacturers would start investing a little bit more money in quality and reliability of their product, because the motivation to build a better product that lasts even longer kind of disintegrates a little bit if there's money to be made in kind of that planned obsolescence type philosophy that we hear about.
Absolutely.
As long as they're making large amounts of money in out of warranty service, I can't imagine the bean counters in the room going, yeah, let's make our products more reliable so that we can reduce that amount of revenue, right? It's counterproductive to that particular goal. In your article, you argue that mission readiness is directly tied to repair access. Can you explain that connection in practical terms?
Sure. A lot has been discussed here over the last few years about, lessons from Ukraine and what we're seeing happening right now, the unfortunate situation that is ongoing still in Ukraine. When you have your support strategy completely delegated to supply chain, and then a crisis strikes, do you really think that the OEM is going to go to the front line to have equipment repaired and maintained? So if you're not in control of your repair capability, mission readiness will be greatly impacted, especially during a moment of crisis. So having access to a well-trained, well-equipped, and valued technicians, engineers has never been more important. Certainly, in our lifetime, considering everything that is going on.
Yeah, and further to that question, you actually cite in your article examples like the CT scanner and the RQ-11 Raven drone to make that point. How common are these scenarios across defense and critical infrastructure? Is this more common now today than ever?
Yes, I would say so, and this argument is based on facts, and based on conversations that we have with our customers, especially delivery agencies, so Air Force, Navy, armies of the world. When they acquire our systems, our circuit board diagnostic reverse engineering systems, they come here for training. They travel here to the UK, or we go out to train them on site. And more often than not, they would tell us their stories and cases involving their relationship with primes and how primes are currently taking 9 months, 12 months to repair a piece of equipment. There was one case in particular in the Middle East, a defense agency, an Air Force in this case, who had a piece of avionics equipment that was out of warranty and needed repair, needed to be repaired. They suspected what the problem was, but they were not 100% sure. So they sent that LRU, the line replaceable unit, back to the OEM in America to be investigated. After 2 months, they heard back from the prime saying, right, okay, so we managed to conduct an investigation here on the equipment, and it's going to cost you $15,000 to have the circuit board repaired, and we might need at least 9 months to get back to you, unless you want to pay a premium fee, and then we might just be able to have that lead time shortened to 6 months. So this defense agency said, you know what, thank you very much, but no thanks, send it back to us. And they had obviously received our systems, so now they run the diagnostics down to IC level. They found a capacitor that was faulty. They replaced it like for 15 cents. And they did that, on the same day. So
15 cents.
So this is 15
for $15,000 repair. 15 cents cost.
Yes. And carried out there and then on the same day.
That's amazing. Operating and support costs can reach as much as 70% of a system's lifecycle costs. How much of that is driven by repair restrictions?
Yes, well,
I'm guessing most of it.
Most of it, yes, and one key part that people don't normally think about is obsolescence and the costs associated with obsolescence, and then how obsolescence and repair restrictions are correlated. So the more restricted an asset is to be diagnosed and repaired by the end user or the OEM, because again, as I explained, they don't normally own the design anymore. They're not in control of the design anymore. They don't make the PCBs. The greater are the chances of that system becoming obsolete and no one noticing. So now all of a sudden, that asset, that fleet that should be in operation for 30, 40 years, guess what? Some critical components are now obsolete. Some critical circuit boards are obsolete, and no one knows what to do with it. The first reaction from key stakeholders, including OEMs and defense agencies, is to go down the route of recertification. Redesign and recertification. And this takes about 5 years and $5 million on average to just have a piece of equipment redesigned, remanufactured. And guess what? That system will go obsolete as well. So it is a kind of a never-ending cycle of waste of opportunities, missed opportunities, waste of resources. It's crazy. So I really think that the industry needs to rethink their strategies and really focus on developing more in-house capabilities for diagnostics, for fault analysis, because then when you learn how or where a fault is developing, then you can always try and adjust that circuitry, make it more robust, more durable as well. Something that you mentioned, in the beginning of our conversation, a lot of systems, unfortunately, they are not designed for reliability. They are designed to cost, not reliability. And now obviously people are talking about design for repair. Well, the reality is most design engineers working these days, they don't know how to repair a PCB either. So how can they design anything for repair? So we have issues related to, obviously cost-driven decisions and a lack of understanding of repairs at, the design engineering level, leading to systems that underperform. Now, when they're obviously fielded and they are commissioned and so forth, in year 2, 3, 4, then we got issues. However, if you do have the ability to identify what is failing, like that capacitor, that 15 cents capacitor, in many cases, components, they are not specified for their reliability, but based on their cost and availability. And then obviously, reliability will suffer. Now, if I'm able to identify those issues and correct those issues, like many of our customers have done so by not replacing like for like, but replacing that transistor for something that is a bit more durable, more reliable, and making the entire system more robust as well. Sure,
an upgrade. I remember when I first got into the electronics industry in 1984, almost all the boards were all through-hole back then, or almost all through-hole back then, very rudimentary surface mount. And most of the dual inline packages, most of the dips were in sockets. And, you could if U4 on the board was deemed to be bad, you just had a little, pair of modified pliers and you just popped out the chip and popped in a new one. Be careful to line up all the pins so you don't bend them pushing it down into the socket. But that was it. I mean, you didn't even have to get out a soldering iron, right? It was really good. And adding to the complexity of right to repair is the fact that, pretty much everything you're repairing now, assuming it's a board level repair, is now soldered to the board, not designed to be removed without some certain amount of special skill. But I've seen manufacturers, OEMs, put an epoxy coating over certain sensitive elements. Part of it is for IP, guarding and things like that. But part of it, I think, is just to say, oh yeah, no one's gonna repair this one, not even us. We're just gonna, it's an argument to replace an entire board rather than repair one, even for the OEM, because they kind of put the poison pill over it. That kind of shows their attention.
Yeah, and you know what? These companies using epoxy rather than a repairable compound, because the option exists, And yes, they cost more, but they are available. These are the same companies that preach sustainability on their websites and on their marketing material. They
Right.
love to talk about sustainability and how their systems are, more energy efficient and, made to last kind of thing. And but if something happens, then eventually you get to know when you get to the nitty gritty of their designs, a lot of the choices they are making are far from sustainable, far from being repair friendly.
From a reliability standpoint, how does in-house repair capability affect downtime, diagnostics, root cause analysis, et cetera, et cetera?
When you have that capability close to the point of use and where the systems are being deployed and used, things can be problems can be resolved much faster because you have the field operators, the operation management, fleet managers. They're all kind of more accessible to help us understand what happened, but more importantly, understand how can we potentially improve the ecosystem where the system lives, for instance, to make it more kind of a robust, more durable. Now, if you don't have none of that or a very limited version of this structure, and you need to rely on a third-party supplier, well, where is that third-party supplier based? What kind of motivation they have to do a good job? They are completely, disconnected from your operation. They have no emotion, no links attached to your operation, and timescale will be months. As my example in the previous case, the cost will be much higher as well. And something that we need to be mindful of, especially in this day and age, is the doors that we're opening when we're sending critical assets to be repaired by a third party. Are we going to be potentially exposing that asset to infiltration of devices that could be harmful, could do the whole system more harm than good? We learned from US investigators just 3 months ago that rogue components were found in solar inverters made in China. Now, nobody knows if those rogue devices that had the ability to call home, or meaning they could be connected remotely and eventually the entire system could be shut down. Nobody knows if those rogue components had been fitted from day one, from the day that they were manufactured, or maybe during the maintenance and repair.
Yeah, sure. Yeah, that's scary. Critics argue that open repair increases risk, which, I can see there's some element of accuracy to that. How does the U.S. Army's move challenge that assumption specifically?
Well, I think, it's I think it's linked to a point that I was mentioning earlier, which is making sure that repair is done following the right procedures. There is an organization called IPC. They have, decades of experience creating standards for the electronics industry, covering design, manufacturing, testing, and repair, troubleshooting, and so forth. Providing that anyone, or someone is following those principles, those standards, using the right equipment, the risk is next to zero. We have, our systems are being used across the world in nuclear power, in aviation, rail transport, and you hardly ever see, any high-profile case involving any of those systems failing. So I think the risks are mostly misconceptions, and linked to myths. Yeah, not long ago I did a podcast numbering 10 repair myths and debunking all the 10 repair myths. Anyone interested in that, they can check us out on LinkedIn or YouTube. And yes, it's called Repair Myths Debunked. Yeah,
that's amazing.
So
and so they search that term on YouTube, they'll find it. It's also, I'm assuming, on all the usual suspect podcast channels like Apple Podcasts,
yes.
Google. all that. Yeah,
that's
great.
correct. Yes, it's available on Spotify as well, and it was a special podcast that we did for International Repair Day in 2024.
And I'll put, for my listeners or viewers hearing that want to find it a little bit more easily, I'll put a link to the podcast in the show notes. So just look there.
Thank you.
What parallels do you see between military sustainment challenges and what manufacturers face in commercial electronics? Do you think that the military, with its fairly unique level of expertise and limitless resources that embrace right to repair, can most or all of that translate to commercial applications successfully, do you think?
I really hope so. And I really hope that the next generation of managers, engineers, because they are obviously coming from a different perspective. They are their relationship with technology is very different to the previous generation, and because they obviously prefer more sustainable practices compared to the previous generation. I really hope that all of this will contribute to a change in the mindset, not just in defense, but in industry and in the commercial world as well. Because we need that. We need a lot more people trained for repair, so that they can design for repair and things can be more sustainable going forward. We can't continue to be generating, tens of millions of tons of e-waste. Not just because we're not coming just from an environmental perspective here, but just in raw materials, in 2024, the world lost $50 billion in raw materials that were discarded as e-waste, and less than 18% of e-waste is being currently recycled. People think that the majority gets recycled. That's not true. And this 18%, in the best case scenario of recycling rate, it's incredibly power hungry, incredibly demanding when it comes to from energy demanding as well. So we can't simply continue to be making designing equipment that should be lasting decades, but being retired within 2-3 years just because a mundane transistor failed.
So looking ahead, how do you see this policy shift influencing OEM behavior beyond defense? Do you see the commercial manufacturers fighting or embracing right to repair?
It's hard to say. Obviously, I'm a positive guy. I like to be optimistic about stuff like this, but I think we're gonna have to wait and see how some of the policies that are being discussed, here in Europe, we're talking about the product passport, how these policies will influence behavior and decision making within the commercial world. I certainly hope that things will improve, and I don't think that anyone should be penalized by the manufacturer's decision of not offering a repair route for their product, because that's pretty much what happens these days. You go to have a product repaired, and you're faced with a much higher than required bill, because the repair is based on complete assemblies and complete, expensive parts being replaced. We're seeing this on EVs. The BMS fails, well, you need to replace the entire battery system, which is crazy, absolutely crazy. So we're seeing a lot of sustainable green technology that is incredibly wasteful. This happens in renewable energy as well, so wind turbines and solar energy. Manufacturers are just going through the motions and focused on the next shiny new thing, and dropping support within 2, 3, 5 years, even though a wind turbine should be running for at least 20 years. So I really hope that things will, the industry will catch up, and whether by design or being motivated by, policymakers.
A good friend of mine has a Mercedes, and it's an expensive Mercedes. It's a high-end one. It's the AMG something, basically the S-Class AMG version.
Mm-hmm.
And one of his screens went out, and the dealer wants $15,000 to replace it. Now,
there you go.
They're replacing way more than the screen, right? They're replacing all the assemblies, bolted to the other side of that screen. Yet, I'm pretty convinced that screen probably has some kind of ribbon cable that attaches to the assembly, and or other type of easily removable connector, because that screen didn't go through the reflow oven when all those things were and when all those components were being reflowed to the board. That was attached. That was probably the last thing to be attached to that assembly. And I mean, to me, that to me negates any manufacturer's claim that they're concerned about the quality of the repair. The fact that many manufacturers, and I'm not saying Mercedes in this case was ripping people off. There was some benign motivation for that, which I really doubt, but who knows? I'll give it that possibility. The fact that many OEMs have been scamming customers, making so much money off of it, to me, in my mind, many have lost the right to make the claim that they're just doing this for our own benefit, because our own benefit should not line their pockets. To me, they just lost that argument. It's like, okay, no, that doesn't carry any weight anymore. You're just going to have to suck that risk up and maybe design your stuff so that customers can more easily repair it, so they don't have to replace any more components than necessary, and that would mitigate that risk. I don't know. That's just life according to Mike. If there was one misconception about right to repair that you'd like reliability engineers to rethink, what would that be?
Mm-hmm. Yeah, that's a very interesting question. Yes, it's difficult to just pick one, but if I have to pick one, I would say...
I'll give you two or three. Go ahead. You don't have to stick with one.
I think the most important one is that a repaired PCB will never be as good as new. Or a repaired piece of electronics, a circuit board will never be as good as new, because this is one that gets hammered a lot within the engineering community. The other one that it takes too long. Why would you do component level troubleshooting? It takes too long. It's not worth it. But I think the to the point of a repaired PCB will never be as good as new. As I said before, if you are following the right standards, if you are, trying, making the most of the opportunity to, diagnose and identify which component degraded. From there, you can not just, as we mentioned about, replacing that device for a more robust version of that same device, but we can also look into identifying the component degradation rate. How fast that component is degrading. And again, we're talking about critical systems, and mostly systems that are designed to last many years, which, currently, the status quo, the MO, is replace the entire box. They replace the entire LRU, $100,000, just like that, spend, give us the long number of your credit card, and we're going to send you a new one. But if we're able to do the component level diagnostics and plot the component degradation rate, then we are able to intervene on the board and maybe do some, replace some of the parts before, they go faulty. So the machine never stops. You can have just a limited inventory of spare parts and keep that inventory, healthy and ready to go. So this is a key misconception, that electronics were designed and manufactured to be like a single-use type of product, and if something fails, you should just throw it away. And if that was the case, then obviously everything would cost a lot more money, because not even manufacturers would be able to make anything. or make any money. If they were spending that crazy amount of money on keeping their production facility going. So I think this is an important one that needs to be reassessed. Technology has moved on. Diagnostics technology has moved on. Standards have improved dramatically. You mentioned about obviously soldering and rework stations. We have X-ray machines. You have BGA rework stations. It's all available, and you know what? None of these technologies would break any bank. It's a very modest level of investment that you require to have a decent sort of a repair operation going.
Didn't the EU embrace right to repair? Was that resolved? Has that become a law for certain types of products within the EU, as far as you know?
There has been a lot of discussions, and as I said, right to repair is definitely sort of a guiding policymakers in the EU. But we're still kind of seeing we're not seeing a lot of practical decisions yet. I think the flagship project is called the product passport, where in order to have any piece of technology supplied into the EU, you would need a sort of a certificate that would estimate or assess a product repairability and give every product a repairability index, and based on that repairability index, you would be either awarded that license and ability to sell your product or not. You're going to have to sort of improve the design further. So this is coming in the pipeline. And there are other initiatives. Obviously, there's a right to repair EU organization. I think they call it Right to Repair, EU.org, and they're obviously trying to lobby decision makers in Brussels to try and sort of change the rules and get as many products into a right to repair bill as necessary. However, based on interim discussions, I'm still seeing a lot of industrial hardware being left out. So wind turbines and solar inverters, defense equipment, for instance.
Stuff that really matters.
Yeah, absolutely.
Well, it's going to be interesting. We'll know who has the better lobbyists by what cutouts are made to any legislation that actually does make it through, right? Like everyone has to have right to repair, except MacBook Pros. I don't know. If Apple has better lobbyists than a solar inverter company, then we might see that in this spotty enforcement. But it's a work in progress. We'll see. But I do like the theme of it. I do agree with some of the arguments on both sides. I do agree with many of the arguments on the right to repair. I do agree with some of the arguments on like, oh, slow down a minute. This could have unintended consequences that could, bring on more liability or whatever. I get that. But I think if products are designed in advance, knowing there is a right to repair, they may be designed a little bit differently to make it not just possible, but easier and less likely to cause more damage, to repair. Maybe certain parts that are a little bit or more prone to failure might be located in an area a little easier to access, so they don't have to dig through everything else to get to it. I don't know. There could be some forward thinking there that could actually make the product better. And as I mentioned earlier, I think if the manufacturers know the consumer has an ultimate right to repair, and that affects their current profit center of after warranty repair, products will get better. And so, at any rate, Willian Santos, thanks for putting up that fight. Thanks for being involved in that discussion. I think it's fascinating, and I'm anxious to see which way it's going to go. I do think that we will see some of it on the positive side. I don't know if we'll see all of it, but I do think that it's the time has come. It's been ridiculous the way the other way has been going, and it's time for the pendulum to swing, and it looks like it's starting to. So Thanks for all the good work. I really appreciate it. If my guests want to get a hold of Willian, I'll have the link to ABI Electronics in the show notes. So if you're watching this on YouTube, just look down here, see more, and that information will be there. If you're listening to this on your favorite podcast app, that information will be in the show notes as well as a link to the podcast Willian was speaking about. So Willian, thank you so much for being my guest. I thoroughly enjoyed our conversation. It's a fascinating subject. Maybe I'll follow up with you in the next year or two and see where we are on this. See how much work you've accomplished.
Okay, Mike. Well, thank you very much for the opportunity.
Before I wrap up, here's a few final thoughts. Reliability isn't just about how well something is designed, it's about what happens when it fails. William's insights make it clear that restricting repair doesn't improve safety, security, or performance. It does the opposite. When trained professionals are empowered with the right tools, data, and access, repair becomes a force multiplier. It reduces downtime, lowers lifecycle costs, and most importantly, restores control to the people responsible for keeping systems operational. If the U.S. Army, one of the most complex and risk-adverse organizations in the world, can embrace right to repair in the name of readiness, then every industry concerned with reliability should be paying attention. And now, that's a wrap on this episode of Reliability Matters. Thanks for hanging out. Whether you listen to it on your favorite podcast app or watched on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, give it a thumbs up and subscribe. Those 2 simple clicks really help us expand our reach. And a huge thanks to PCB Chat from the Printed Circuit Engineering Association at PCBchat.com and Ascendo Reliability at Reliability.fm for syndicating this show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@reliabilitymatterspodcast.com. Want to learn more about the podcast? Just head over to reliabilitymatterspodcast.com. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.